Chapter 1, The Structure of Science, Scientific Methods and Revolution. Introduction. All disciplines have their own structures. Discipline means different areas of study like science, art, and commerce. Structure means the organized way in which knowledge is developed, validated, and applied. Not all disciplines have their structures properly described. This may be due to different ages of disciplines. Science has a structure that we can say cuts across all disciplines known by name. This means that other disciplines as well has similar components in their structure as contained in the structure of science. For example, in science we could have the following. Most of this so-called component of science can be found in other disciplines as well. For instance, theories and laws in economics, government, and so on. An attempt will be made in this chapter to describe the structure of science. Knowing the structure of science has its values. Science students and all those interested in the subject will know the components of the discipline, and they will be able to relate to the discipline in a conscious manner so that during the learning process they'll be able to know what they're learning. The knowledge of the structure will also enable them to know how they can be scientifically literate persons through judicious combination of knowledge and applications of the components of the structure of science. This statement is talking about the significance of knowing the structure of science. Here's an illustration. Assuming you just got a new phone and you have a guide showing you different resources on the phone and how to navigate through it and make full use of what the phone can offer. So also, this chapter aims to familiarize you with the structure of science so that you can be a literate of science and also be able to exploit its full potential. Also, science teachers will understand what they're teaching their students better if they understand the structure of their subject matter. This knowledge will assist them to know how to properly organize science content for instruction. Evaluation of students' learning outcome will be enhanced through this knowledge. First, different definitions of science are presented to demonstrate an awareness of various misconceptions about science. Second, the three components of the structure of science are presented in great details, one after the other, to demonstrate what a scientifically literate person needs to possess for knowledge, skills, and attitude. Finally, the chapter concludes with science functions and limitations. Note the words knowledge, skills, and attitude. This will help you to better understand product, process, and ethics as components of science structure. Objectives. At the end of the chapter, students are expected to define science, identity, the components of the structure of science, identify and describe the product, process, and ethics of science, describe the function of science, describe the limitations of science, identify the three characterization of the 17th century, describe the history of the two major forms of scientific methods. Describe briefly the life history and achievements of the major scientists of the 17th century. Describe the organization and the roles of the major early scientific societies or academies during the scientific revolution. List major 4 scientific societies or academies in Nigeria. Discuss the relevance of the three characterization of the 17th century based on the major events of the century. Definition of science. Definition of science varies from scientist to scientist and from one subject area to another. Take note of the words knowledge, ways, and search as we will be using them quite often. They also show what science is basically all about. Some describe science as an ordered body of knowledge, while others defined it as a search for explanation to natural objects and phenomena. Phenomenon means an observable event. For instance, when you throw an object upward, it falls down. This is a phenomenon. The search for the knowledge of the cause is known as science. From the definition, it is clear that the objective of science is to gain knowledge. Generally, science can be defined as a body of knowledge, a way of investigating or method, and a way of thinking in the pursuit of an understanding of nature. From this definition, we can see that science is defined from 3 different perspectives. Perspectives of what's being gained. That is knowledge. Perspective of actions involved while searching for knowledge. That is, investigating. Perspective of attitude towards and motive for getting the knowledge. Therefore, we can view science as a noun, verb, and an adjective. Do not forget that the components of the structure of science are products, process, and ethics. And science can be defined based on each of them. based on product, in other words, the result of the search or what's being gained. It's defined as knowledge gained in form of concepts, facts, generalizations, principle or rules or laws and theories, subject to change. For example, one of the early scientists once said, if you acquire a trait, for instance, you train your body and develop huge muscles that your offspring can acquire the trait from birth. At that time, people agreed to it to be true until many years later, when another scientist discovered that wasn't true, but that traits can only be inherited through genes. That means if I am black and I bleach my skin to white, that doesn't mean I'll give birth to a white child. Definition of science by process. This means before a scientific knowledge is gotten, there are some steps taken in procedures and actions. Take note of the word action. We can also define science with its motive or ethics or attitudes that guide the day-to-day activity of scientists. Selecting any of these aspects to define science would be inadequate and misleading. We can consider science at present as an enterprise in which human beings participate to study and give parsimonious, limited explanations of the materials and forces of nature. We should take science as human enterprise, the consequence of which has human implications. In the teaching and learning of science, all aspects of science needs attention. Products of science, they include concept, fact, generalizations, laws, theories. Concepts is the meaning we attach to a given symbol or label. For example, words, formulae, mechanical models. For example, in gender declaration, after studying a person with some physical features, such as the reproductive organs, one can say whether it is a male or female. That's what concept is all about, the meaning we give to something. Types of concept. 1. Empirical concept. 2. Theoretical concepts. 3. Relative concepts. Empirical concepts are concrete and observable concepts. For example, if I say a person is male, I can see the features that make that person a male. Whatever can be observed through the human sense or instrument is empirical. Note: philosophers limit observable things to things that can only be perceived with the human sense, while scientists extend it beyond that. For example, temperature is empirical because it's measurable with an instrument. Theoretical concepts. These are concepts that can be observed but can't be seen or abstract, e.g. molecules, absolute zero, gene, and so on. Relational concepts. These are concepts that relates, or in other words, compare concepts together. They cannot exist on their own, e.g., less, more, inverse, proportional, etc. facts. A fact is another product of science. It is an event that happened in the past that people recorded with no disagreement among observers. In order to remember each definition very well, it is important to take note of the keywords in their definitions. Concept meaning. Fact event. For example, an insect is said to have 3 pairs of legs. This wasn't the case in early days. In early days, scientists classified 4-paired legs as insect also. This means facts can change. Example is a spider and a fly. A spider, according to science, is not an insect, but a fly is laws. A law is also a product of science. It is defined as brief statement or mathematical formula predicting interrelationship among concepts. It describes the regularity and order in our observation. For example, when you throw a ball under gravity, it will always come down. Note: it is not right to say someone breaks scientific laws because they are not commandments, but it is right to say they are abandoned or modified. There are 2 types of scientific laws. 1. Empirical laws. 2. Theoretical laws. Empirical laws. By now you should have an idea of what empirical means. It means observable and visible, or the concepts that forms it can be measured or sensed. Example is Ohm's law, which talks about current and voltage, and both can be measured. Theoretical laws. They are formed by concepts that can be observed but not visible. They can be measured indirectly but without an instrument. Note: theoretical laws both predicts and explain, and can be used to form empirical laws. Theory. A scientific theory is more advanced than a law. A theory combines several laws in its formulation. It's defined as a system of logical reasoning that scientists carefully construct to explain the unknown, based on valid assumptions about natural phenomenon. These means a theory will have several laws brought together. Note: a law can consist of a single statement, while a theory will consist of several laws, or statement called logical reasoning. For example, Ohm's law is just a statement, but John Dalton's atomic theory is more than one statement put together.